Welcome. This is the Chapter 3 Review Packet Solutions. This is page 3 that I'm going to go over, okay? So before you do 23 and 24, you have to look at the core concepts, okay? You notice that two triangles are similar, and here I'm only looking at the angles, okay? If all, so here, if all the angles are the same, values in both triangles, then you'll say the triangles are similar. So this is 50, 55, and 75 degrees, which is similar to this triangle, which is also has the angles 50, 55, and 75. Okay? In geometry in high school, technically you only need two. And we call this the angle-angle theorem. Notice that two angles of a triangle are congruent or similar. If two angles of one triangle are congruent to two angles on another triangle, then the two triangles are similar. Here are your two triangles, 55 and 50. Here's 55 and 50. These two are similar. Okay, you only need two matching angles among two triangles to say that they're similar. Because when you try to work off the math, they're going to set up the same equation and solve for the same unknown. So their third angles are going to be the same. This is the reason why you only need two congruent angles to determine that two triangles are similar. All right, 23. Here I have 28 and 80, 28 and 71. So I can't use these two. So I have to solve for the third one. So I have to solve for x. So it is here. And I have to solve for y, but I'm going to solve for x first, okay? So it is x plus 28 plus 80 because this is your interior angles. Okay? And we know that the total interior angles inside a triangle is 180. 28 plus 80 is 108. Subtract 108 to both sides, you get x equals to 72. Okay, so this is 72 degrees. Now you're going to solve for y. Again, you do your interior angle theorem. So 28 plus y plus 71. I just wrote it in a different order. Y plus 28 plus 71 equals 180. Okay, 28 plus 71 is 99. Subtract 99 to both sides, you get y equals to 81. So your first triangle, you have 28 degrees, 72 degrees, and 80 degrees. Your second triangle was 28 degrees, 71 degrees, and 81 degrees. Are these the same? No. So since all the angles are not the same value, you would say that the triangles are not similar. 24. Do they have two matching angles? No. So I would have to solve for their third one. So the first one, it's x 66 and 90 degrees equals to 180. So add these two together. 66 plus 90 is 156. Subtract to 156 to both sides. You get x equals to 24. Next one, solve for y. Y plus 24 plus 90. 90 plus 24 is 114. Subtract 114, you get y equals to 66. Okay. Your first triangle angle, okay, are 24, 66, and 90. And your second triangle is 24, 66, and 90. You would say since all the angles are the same, the triangles are similar. Next, I just want to review this core concept with you. You could either set up the ratio. How am I setting up the ratio? Okay, I went this side divided by this side. So it's going to be this side divided by this side. 7 over 15. And the other one's 21 over 45. And I have to reduce that. That becomes 7 over 15 because you pull out the greatest common factor of 3. So you would say that the two triangles are proportional because they have the same value ratio. Their values are the same, which is 7 over 15. Or you would say the two triangles are proportional because there's a dilation of 3. So again, you can justify this by using the proportional rules that you learned in 7th grade, or you can use the core concept of a dilation and scale factor. Because notice that 7 goes to 21 by multiplying by 3, and vice versa to the other sides. Okay. All right. So 25. You're going to tell whether the triangles are similar. Okay. You have this triangle and this triangle. You can't really compare it because this is in a weird angle. So what I'm going to do is I'm going to flip it. See, I just flipped the second one. Now it looks like this. So I would say the two triangles are similar because there's a scale factor of 2 from the small triangle to the larger triangle. Let me show you. So from 4, so from 4 to 8, you multiply by 2. From 2 to 4, you also multiply by 2. From 3 to 6, you also multiply by 2. Okay, or you would say that the triangles have equal proportions. So check it out. I did 8 over 4 and 4 over 2 equals to 2. Notice the scale factor is the same thing as the ratio on the proportion. Okay, 25. They're already all the same. They're ordinated at the same place. Okay, so I could set up the ratio and look for the scale factor. Okay, so you would say there is a scale factor because to go from 15 to 10, you are actually multiplying it by I did this wrong. This should be a 2. It should be a 2 because you're pulling out a 5 here. You're pulling out 5 here. So from here to here, you're multiplying it by 2 over 3, or 2/3. Okay. Same thing here. From 3 to 6, you're multiplying by 2/3. From here to here, you're multiplying it by 2/3. Okay, because 10 over 15 is 2 over 3. Okay. Or you would say that the two triangles are also similar because they are proportional. It's not 15 over 3 is 5 over 3, and 10 over 6 is 5 over 3 as well. Okay, so this was a little mixed up, right? So notice that this triangle goes to this triangle because of the scale factor of 2, 3, or because if you set up the proportion, they're the same. All right, that's it. Okay, that's all your page 3.